An AI can pass the uniform bar exam in the 90th percentile. It can write a Shakespearean sonnet about quantum physics in 3 seconds. But if you ask that same AI to book a window seat on a flight to Tokyo and find a hotel with a gym nearby, it will likely fail. It might get stuck in an infinite loop on a travel site or hallucinate a flight that doesn't exist. This is the agentic paradox. We have built the world's most powerful digital brains, but we are still struggling to give them hands. To understand why they fail, we first have to define what an agent actually is. A standard chatbot like ChatGPT is a storyteller. It takes text in and puts text out. An agent is different. It's an AI that uses tools to achieve a goal. It doesn't just tell you how to book a flight. It logs into the website, navigates the UI, and handles the payment. Or at least, that is the promise. In reality, moving from a chat window to a real-world workflow introduces a level of complexity that today's models find overwhelming. The technical term for this is the long horizon problem. Most humans can easily manage a task that requires 10 or 20 substeps. But for an AI, every additional step is a point of failure. Current research suggests that once a task exceeds a handful of discrete actions, the probability of the agent drifting off course skyrockets. It loses the thread of the original goal. This is why an agent might start searching for flights, but end up reading the airline's Wikipedia page for 20 minutes. New research, like the 2024 paper on VS co-scientists, argues that the problem isn't just the AI's brain, it's the equipment we give it. They call it the agentic harness. Think of it like a safety rig for a mountain climber. Without a harness, the AI is just a floating brain. The harness is the software infrastructure that provides the AI with 3 things: specific domain memory, a way to verify its own work, and a literal connection to tools like data visualization apps. Here is the uncomfortable truth. AI agents lack common sense error handling. If a human hits a page not found error, they try a different link. An agent might try to refresh that 404 page 1,000 times until it burns through $50 of API credits. This lack of a reality check is why autonomous agents haven't taken over our offices yet. They are brilliant, but they are also fragile. The goal is shifting from do-it-all bots to specialized co-scientists. These are agents designed for high-end, multi-domain tasks, like analyzing complex scientific data and then independently coding a custom app to visualize it. This requires the agent to be more than a chatbot. It has to be a designer, a coder, and a researcher all at once. The research shows that when we build a harness specifically for these complex tasks, the agents actually start to work. We are currently in the unreliable phase of AI agents, much like the early days of the internet when dial-up dropped every 10 minutes. The transition from chatbots to co-scientists won't happen because the models get bigger, but because the harnesses get better. We are moving toward a world where AI doesn't just answer your questions, but actually does the work correctly the first time. The next time you see an agent fail at a simple task, remember, it's not that the AI is stupid. It's that the bridge between its thoughts and its actions is still being built. The agentic gap is closing, but for now, the most important part of the system is still you. If you want to see how these harnesses are being built, there's a link to the primary research in the description. Thanks for watching.